Hello guys, welcome back to my channel Algorithm Minds. My name is Asan Khoram and in this channel I teach programming skills in Python, MATLAB and R programming. I also teach Tableau, a data visualization tool. So for today's tutorial, I'm going to teach you how you can use this specific function in MATLAB called interp1 and find the interpolated values of 1D function. So what function is this? So basically this is a form how you define a function. We write the function name interp1, then we pass number of input arguments. So what it actually returns, it returns interpolated values of 1D function at specific query points. So we have like x and v. X are the values and v are the target values here in case. Okay, and here we define specific query points are actually the xq. So by default, interp1 uses linear interpolation. Vector x contains a sample point and v contains the corresponding values, which are the function of x. And now when we using specific query points xq, that will actually be used in order to say, okay, these are the actual x values which we want to interpolate or which we want to predict by the interpolation. Okay, so that being said, so if you have multiple sets of data that are sampled at same point coordinates, then you can pass v as an array. Okay, so which we are going to discuss further on in this tutorial. So let's move on and actually discuss the code. So first of all, we are going to create a data set that will actually help us to implement that interp1 function. So the first one is actually we are using colon operators here. It starts with 0, it ends at 2 pi and with the interval of pi over 4. So these are the x values. Okay, and based on those x values we will have v, which is a function of sine of x. So whatever the values that are currently present in x, which is in the form of array, it will generate an array of sine values that will be stored in v. So once we done that, the next thing we are going to do, we are creating a specific query points, which in our case is xq. So it starts with 0, it ends at 2 pi, but the interval after each point will be pi by 16. So here we will have by definition more points as compared to this point, but the limits of these x-axis, x and xq will be the same, 0 to 2 pi. Now once you have done that, what we are going to do, we are going to initialize a figure space by using this MATLAB statement, and then we are going to use this function interp1, and we are passing 3 input arguments. The first input argument actually is the x values, the second input argument is actually the function of x values, which is v, and the last input argument is actually the specific query points for which we actually want to interpolate the data. Okay, now once you run that, you will have the values for vq1 that will correspond to xq. So that being said, now we are going to just simply plot those values using the function plot, and we are passing number of input arguments. The first set is the set of input argument belongs to plot 1, and the second set of input argument belongs to plot 2. The first input arguments like xv are the actual values which we generated by the use of this colon operator, and it will be plotted in the form of dot circles like here you can see in the diagram. And the xeq, which has more data points but has equal range, and veq1 will be equal to the size of xq, and here we want to plot this data set in the form of this format like double colon and dot. So that is exactly, you can see that it is plotted in orange color. And finally we are setting the limit of our plot for x-axis by using this function xlim, and we are passing an array with 1 row and 2 columns. The first one is actually the initial point, the second one is actually the final point of the or final limit of the plot, and finally we'll use title to display the parent. So this is how the plot will look like. Now you can see that the circles with blue color are actually the values, actual values of x and v, where this dotted line with a bold dot and somewhere in between is actually the more refined form, and it is actually the interpolated values of xeq. So that's how you can actually use interp1 function in MATLAB. But there are a number of use cases that you can use in order to change the functionality of our functions. Just in this case, you can see instead of like passing 3 input argument, we are passing 4 input argument, and the last input argument is actually the method that specifies an alternative interpolation method. So MATLAB but has a number of methods that we can use in order to interpolate the values. As you can see the list, we have linear, nearest, next, previous, p-chip, cubic, v5 cubic, Makima, and spline. Okay, so by default it is uses linear, but let's move on and actually change this function to spline. So now you can see that we are created and initialize a new figure, and we have initialized a new variable vq2. Okay, then we are calling the function interp1 and passing 4 input argument. The 3 input arguments remain the same, and the last one is actually the method of interpolation. In our case, we have set it to spline. Now in the same way, we will plot the actual xv values and the interpolated vq2 values, and in the same way. Now you can see that spline has actually given a more better representation or interpolation of the values of the function. So this is it, and finally let's move on about and talk about extrapolation. Okay, so you have to define to this function that you are actually extrapolating the values. So what does extrapolation means? That something that was not present in the range of x, now you are actually extrapolating or giving value that is beyond the limit of actual x values. So this function specifies a strategy for evaluating points that lie outside the domain of x. Okay, so for example, we have like x, which is a matrix of 1 row and 5 column, 1 2 3 4 5, and we have its b value 12 16 31 10 and 6. Now that being said, we will actually extrapolate and find the value with respect to 6. Okay, now you can see that the 6 is not present in x. It's like it ends at 5, so x is beyond the limit of 6 is beyond the limit of what is actually present in x. Now what we are going to do here, we will this is the form way of actually writing the MATLAB function. So we will initialize a new variable named vq3, and we will call the function. The first 3 input arguments will remain the same, and the next thing we are going to tell that we are actually what kind of method we are going to use for interpolation. We are, in this case, we are using it linear, and the last thing we actually have tell to this function that we are using it for extrapolation. So this is an additional input argument that you have to define when you are going for extrapolation. And this is the result of this variable. These are the actually interpolated values of xq. Okay, so that's how extrapolation works in MATLAB with the function interp1. Now the beauty of this function is such that you can interpolate multiple set of data in one pass. Sample points specified as row or column vector of real numbers. These values are in x must be in distinct. The length of x must conform to one of the following requirements. Okay, so let's move on and actually plot multiple values, handle multiple values, and then interpolate multiple values at a single time. So in this case, the x value will remain same, but the y value, we will like to have different kinds of functions of x. So we have first created an x value that starts with -5 and ends at 5 with an interval of 1. Okay, and we are using transform style, which means that we are changing it from row to column wise. And here we are actually creating 3 set of values for the x variable v1, v2, v3 with different kind of formula. The first one is x1 square, x square, the second one is 2x square plus 2, and the last one is 3x square plus 4. So it will create a number of set of values that will be corresponding to the set of values that is currently present in x. Okay, so we will have equal amount of v values, v1, v2, v3, and once we do that, what we are going to do, we are simply going to compile them into a single matrix. So here we have like 3 rows, 3 columns, and rows depends on what kind of value, whatever the number of values we have present in X. Okay, so once you've done that, let's move on and actually generate the value of set point queries. In this case, we would like to be more refined as compared to what we have actually generated in X. So for SQ, we are starting at -5 and we are ending at 5, but here the interval is 0.1. So it is more refined as compared to the X. Now we are simply going to use the same approach in defining the function. First of all, we will initialize a variable vq, and we will equate this value by calling the function interp1 and passing for input argument. The first one is actually x, which has value from -5 to +5. Then we have like 3 set of v values where each column correspond to a different function of x, and then we have xq, which is the more refined form of x, which is actually the value that we actually want to interpolate the values. And finally, what we defined the method for interpolation. So it is another method of interpolation in MATLAB for this function interp1. Then we are going to initialize figure. Then we are simply going to use plot function and pass v x b, and the marker is that we are setting that we want marker to be this. And for the second line of plots, we are simply plotting the line function. And here we are setting the limit of x-axis from -5 to 5. So now you can see that we have 3 different functions of v1, v2, v3 that has been interpolated with the help of this function. Here marker are the actual values, and here while the line is actually the interpolated values. So this is how you can actually use interp1 function in MATLAB. I hope this tutorial has been helpful. If you have any question regarding today's tutorial, feel free to write down your comment. I will be happy to help you out. Thank you for joining me, and I will catch you soon in the next video.